All right, welcome to part 2 and this point right here. Using these same values, can you give me the coordinates of this point? We're on a coordinate plane, this is the origin, and we're going to go back this far and get right under this point and then go up. So, can you see this is long and this is short? So the long guy, and we went back, was negative square root of 3 over 2, and we went up 1/2. All right, see if you can name this one, skipping that one, this one, and this one. See if you can get them while I put them up. Okay, how did you do out there in video land? Let's check. Here from the center I went over long, down short. Negative square root of 3 over 2 and negative 1/2. They're both negative, back and down. This one, however, I went over short and down long. Negative 1/2, negative square root of 3 over 2. But I got over here, how do I get from the origin to this point? I went over short and down the long. And here I went over long and down the short. So hopefully these values make sense to you. And if you can remember the short one, 1/2, and the long one, square root of 3 over 2, you can find them no matter where you are on the unit circle. All right, let's fill in the ones that I skipped. And when you're on the unit circle, every point on the circle is 1 away from the origin. So this point is on the circle, it's 1 away from the origin, so its coordinates are 1 to the right and 0 up and down. First coordinate tells you how far right and left, second coordinate how far up and down. What would the name of this one be? Alright, so this one you don't go any right or left, and so it's 0 right and left, but then you go 1 up. And this one, you go back 1, and you don't go up or down at all. And down here, you go straight down 1. You don't go, the first number is right or left, you don't go any right or left, and then you go straight down, negative 1. Alright. Believe it or not, there's another part to the unit circle which involves the quarter marks. And if I like to put them all on one, but it's just too jumbled up. So I'm going to have to draw another unit circle to put in the quarter marks. So let's see what that looks like. Here's my unit circle. I can divide it into fourths, and this time each fourth is divided in half. So the whole circle has 8 equal pieces here. Usually we do the quarters with dotted lines and the sixth with solid lines. No real requirement for that. It just helps our eye to catch them better. So I need to know this point, this point, this point, this point, and the radian and degree measures. Here's 0 radians. So this is 1/4 of our way over to pi. So we have, I'm doing the radians inside, sorry, pi. So from 0 to pi is, 1/2 is 0 to pi. So this is 1/4 of the way. So we have pi over 4, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, and 7/4 pi. So 1/4, 2/4 is pi over 2, 3/4, 3 pi over 1/4, 2/4, 3/4, 3 pi over 4, 4/4 is 1 pi, 5/4, 5 pi over 4, 6/4 pi, is reducible to 3 pi over 2 and 7/4 pi. So it's going around 7/4 pi. Going around similar to how we did with 6, but only with fourths. Let's put in the degrees. So this is 45, 90, 90 and 45. Come on, you can do this. 135, and another 45 is 180, and 45 is 225, and 45 is 270, and 45 is 315, and 45 brings me up to the 0 line again, or 360. 2 pi for radians. So that line has a lot of names. All right, now we need the coordinates, and put the dots in everywhere. We already got these. I'll put them in 1, 0, 0, 1. This is the monkey math. These put negative 0, negative 1, 0, and 0, negative 1. All right. We're going to borrow from our special triangle that was sitting over in the corner, calling to us. Say, I can help you. 45, 45 gives us a 1, 1 square root of 2. So I'm going to pull it back over here, and I'll move the camera in a sec. All right. So my 45, 45, 90 special triangle is going to help here. And what it's going to do for us is it's going to help us get those coordinates. So I'm going to pull out this piece of the pie, that triangle right there. I'm going to pull it out over here, and I recognize it's a 45-degree triangle, so it's going to be proportional to these values. Every 45-degree triangle, right triangle, is proportional to these. But I already have some spots that are set in stone. This hypotenuse is a radius of this unit circle, so this is a 1. So, how am I going to get this from this, or how am I going to get from this to 1? The way I could get from here to here is to divide this by the square root of 2. And proportionally, I have to divide this by the square root of 2, and this by the square root of 2. But that's poor form. Alright, so we rationalize that by multiplying the square root of 2 over the square root of 2, and we get 2, square root of 2 over plane 2. So we went over rationalization today of the denominator again, so that should make sense to you. Alright, so the special number that it will help us with 45, and we'll call him the middle guy because he's not quite as long as 1/2 the short guys, and he's longer than a short guy, but he's not as long as square root of 3 over 2. So square root of 2 over 2, we'll call him the middle guy. So we need to add that to our memory, and we build a unit circle. So on this one, we went over square root of 2 over 2 and up square root of 2 over 2. So this coordinate right here, thank you unit circle, thank you special triangle. Square root of 2 over 2 over, and square root of 2 over 2 up. Alright, how about back here? We already got this point. What about back here? Since we're still using the 45 relationships, we go back, the legs are the same for the 45 degrees, so we go back, square root of, back is negative, square root of 2 over 2, and up square root of 2 over 2. Notice these will dance around the quarters, and they will have always square root of 2 over 2 on each coordinate, but with different signs. So up here they were both positive. Over here the first one was negative because the x-coordinate went back, the y-coordinate went up. How about here? negative, we go back and then down. So they're both negative. And lastly, this one, to get to this one, we have to go to the positive direction in the x direction and negative on the y. All right. Let me get rid of these cluttering things. All right, so this is, you have to come up with this by heart. But I hope it's not a memorized thing, it's an understood thing. Let's see if I can get both of them in. All right, and again, we can't actually put all of them on one, but it seems a little much here on the board. All right, so why? What is the big deal about these unit circles? Well, the power of the unit circle is coming upon us quickly, and I think that I'll introduce it and then start part 3. It turns out here that last night we could come up with sine, or last lesson, sine, cosine, tangent, and the other three trig functions of 30 and 60 and 45. But that wasn't a whole lot. It was helpful, but without a calculator and any other aid, those are the only ones we can come up with. Now today, I give you the power of the unit circle to come up with the sine, cosine, tangent, and any other of the 6 trig functions for each of those spots and each of these as well. And I'll show you how on the next section. So stay tuned to part 3.